So previously, we learned the definition of data science and the steps in a data science workflow. In this lesson, you will learn how data science can be applied to real world problems. Let's take a deep dive into three exciting areas of data science: traditional machine learning, the Internet of Things, and deep learning. So suppose you work in a fraud detection at a large bank. So you would like to use data to determine the probability that the transaction is fake. So to answer this question, you might start by gathering information about each purchase, such as the amount, date, location, purchase type, and card holder's address. So you will need many examples of transactions, including the information, as well as a label that tells you whether each transaction is valid or fraudulent. Luckily, you probably have this information in a database. These records are called training data and are used to build an algorithm. So each time a new transaction occurs, you will give your algorithm information like amount and date, and it will answer the original question, which is what is the probability that this transaction is fraudulent? Before we can answer that question, let's walk through another example and highlight what we need for machine learning to work its magic. First, a data science problem begins with a well-defined question. Our question was, what is the probability that this transaction is fraudulent? Next, we need some data to analyze. So we have months of old credit card transactions and associated metadata like date and location that have already been identified as either fraudulent or valid. Finally, we need additional data every time we want to make a new prediction. We need to have the same type of information on every new purchase so that we could label it as fraudulent or valid. Now, suppose you are trying to build a smartwatch to monitor physical activity. So you want to be able to auto detect different activities such as walking or running. So your smartwatch is equipped with a special sensor called an accelerometer that monitors motion in 3 dimensions. So the data generated by this sensor is the basics of your machine learning problem. You could ask several volunteers to wear your watch and record when they are running or walking. You could then develop an algorithm that recognizes accelerometer data as representing one of those two states, that is either walking or either running. So your smartwatch is a part of a fast growing field called the Internet of Things, also known as IoT, which is often combined with data science. So IoT refers to gadgets that are not standard computers, but still have the ability to transmit data. So this includes smartwatches, your connected home security systems, then your electronic toll connection systems, right, that you see on your highways, uh, and much more. So IoT data is a great resource for data science projects. Let's tackle another example. A key task for self-driving cars is identifying when an image contains a human. So what would be the data set for this problem? We could express the picture as a matrix of numbers where each number represents a pixel. However, this approach would probably fail if we fed this matrix into a traditional machine learning model. There's simply too much input data. So we need more advanced algorithms from a subfield of machine learning called deep learning. So in deep learning, multiple layers of many algorithms called neurons work together to draw complex conclusions. Deep learning takes much more training data than a traditional machine learning model that is able to learn relationships that traditional models cannot. So basically what your model is, so there are basically many user defined models that are already available on the internet. Okay. So basically the models perform as a black box. You feed in your data, then that model does its computations. In the form of computations, what it does, it trains the data. What do you mean by training the data? It is like, in simple words, it scans through the entire data. Okay, just like you, if you are preparing for an exam, you scan through your textbook, right? You learn your textbook. So basically, in formal words, it is called training your data. So basically, you feed the data to your model. It does its own computations, which is your training and everything, and then it predicts your output. So that is why we use machine learning models, and this process of everything, feeding the data, training your data, and predicting is comprises of our machine learning workflow. We will see that also in the Earth slides. If you have more doubts, or if you want to learn into more depth, we have that slides ahead. It is based on statistics. So basically your math and statistics is the backbone of the machine learning model. That is why it is said that before diving into machine learning, it is useful if you learn, if you master your statistics. So that is why we always teach students statistics before we teach them machine learning. And
Okay,
yes,
so
basically a machine learning model is just a combination of different mathematical calculations. Yeah, you can say that. It is not like we need to know a lot of mathematics. See, the just the basics. So in your 11th or 12th grade, if you're learning, if you're from USA or if you're from India, if you're studying from so all the concepts that we taught in 11th 12th standard, right, all the matrix and everything, so that will be useful, that will prove useful to us when we are learning about statistics. So it's not like we need to know a lot about maths. Okay, you know, don't need to be a statistics ninja or any sort of thing, but yeah, just basic statistics, which is very easy for you to understand. Like anybody can learn it. It's not like even if you are weak in maths or anything, you won't understand it. Yeah, so simple. It is not too much. Exactly.
okay,
So if you know about maths, you will be able to tweak your model accordingly. So there are many arguments that we'll see ahead when we will do machine learning. So there are arguments that you can tweak, and so if you know about statistics, then it will help you a lot basically. But if you still don't know, then it's fine as well. You can still work around with machine learning.